morning. There it goes. You have a good weekend? Kind of? No?
I work all weekend.
Work all weekend?
Yeah, I don't get days off.
Good morning.
Come on. The weather was nice though, it's beautiful.
It was.
At least this, I didn't have to actually watch some soccer, so I could be outside.
I cut my son and daughter-in-law's cypress trees down Saturday. And hauled them and a bunch of other things from our house to the dump. What else I did? Oh, I worked on our fence. Exam on Friday. And we had the review posted. You still have time on 10/7. That shuts down tomorrow night. I posted 11/1 this morning. We're going to do examples for that today, if there's time. But any questions on 10/7? Closes tomorrow night. Anything on the review? Have you guys started that? I didn't look.
I haven't started it.
Haven't started it?
Today. Today's my day.
Okay.
Oh, he's got a question.
Yeah. Can you give me a quick 13 in the review?
Yeah.
13?
Yeah.
Good
Oh,
morning.
not in the review site, on
10/7?
Yeah.
Okay. Question 13. Use the ratio test to determine whether this series converges absolutely or diverges. All right. I have a bunch of pens here that some of these are right. So good this one is. We got the sum. That's pretty good. K equals 1 to infinity. E to the negative 2k. And it says to use the ratio test. All right, ratio test. All right, to use the ratio test, we're going to do R equals the limit as k goes to infinity. I'll show all the detail here. The k plus 1 term on top, k plus 1 times e to the negative 2 times k plus 1 over k e to the negative 2k. This is all in absolute values. All right, we all okay with that? Is that good? So from here, there's probably going to be a bunch of algebra. As we put in positive values for k, does everybody see this will always be positive? So we can leave off the absolute value. Yeah? So this will equal limit k goes to infinity. I'm going to leave off the absolute value. And I'm going to group things here. This k plus 1 over k. So imagine that there. And I'll distribute the negative 2 up there. So we have e to the negative 2k minus 2. Like this. All right, first, there is not an exponent on this, so what's this going to go to? 1. This is like it's a rational expression, a polynomial over a polynomial, and it's degree 1, so it goes to the ratio of the leading coefficients, right? Which is 1 over 1. So, that's going to be 1. What do we do with the exponents here? Subtract. So I'll do some scratch paper work over here. take the exponent on top, negative 2k minus 2, and subtract the exponent on the bottom, minus negative 2k. All right, so this double minus gives us plus there. Oops. The negative 2k in the front and the 2k there cancel out, and negative 2 is left. So we have e to the negative 2. That's a constant, isn't it? So our answer is e to the negative 2, which is like 1 over e squared. Is that value less than 1 or greater than 1 or equal to 1? That is less than 1. And what does the ratio test say? It converges. And it converges absolutely. By the ratio test. Okay. Does that help? Remember, when something converges absolutely, it also converges in alternating form. This is not in alternating form, but it would also converge in alternating form. So when it converges absolutely, you can say it just converges in general as well. If it converges in alternating form, but not in absolute form, then it converges conditionally. Remember that? All right, let's see if my lab lights will work. All right, so we said it converges, so that would be B here, because R equals 1 over E squared. There you go. All right, any other questions here from 10.7 or the review? Good morning. Morning. Everybody's good? All right, we're going to